Yay! My name is Aaron, and I am delighted to introduce our next speaker. I'm going to add the screens to this screen, and then I will tell you something about our speaker, because there's a lot to say. All right, thank you all so much for joining. Professor DeMello comes to us from UC Boulder, where he's a part of the Cog-Sci and Comp-Sci departments. He has co-authored 7 books. He has published over 300 papers, and he sits on the board of 11 academic journals. And he is also currently running the NSF ISAT program, which he's going to tell you all about, the NSF Institute for Student AI Teaming. And it's trying to found a socio-collaborative artificial intelligence enrichment program for all students. And I'm sure he's going to tell you all about it. Please welcome Sidney DeMello.
Thank you. Thanks, guys. It's really great to be here. I just want to start by telling you a little bit about myself and kind of my journey. I actually graduated 20 years ago in 2002 with a degree in computer and electrical engineering, but mainly computer science. And back then, we were actually in a recession because of the dot-com bust. And I remember going to job interviews, and they would tell me, we're just here so we have our own jobs. There's no job. So I decided to go to grad school and get a master's degree. I never even considered it. I had no idea what grad school was. I didn't know what a journal was. And it was one of the most transformative decisions of my life. I got connected with a great group of advisors studying artificial intelligence. We were trying to figure out machine consciousness at the time. That's when I really started getting fascinated by thinking about psychology, how the mind works. And at that time, we were thinking a lot about cognition, how thinking occurs. And people were starting to realize, because we could suddenly look into the brain and understanding that the way we thought about emotion and cognition as being very separate were very integrated. So then we started looking at emotion and so on and so forth. So it's just been really amazing how I've been so fortunate to think about how to blend psychological sciences with computer sciences, and they actually have a really natural home. So one thing you may know is the kind of the revolution of deep learning actually came through the key algorithm was discovered by a group of cognitive scientists from UC San Diego in the 80s, actually. They rediscovered and they got AI out of its AI winter. So there's been a very, very good blending of the two fields. So that brings me to the talk today. What I want to talk to you about is thinking about AI in education. And if you're actually thinking about AI, which is computing, and education, which is about learning, how do you put those together in a meaningful way that AI can actually support learning? And I want to talk to you about some perspectives from what we've been thinking about for the last 2 years from this center we're running of student and AI teaming, okay? So first of all, we're one of currently there's 18 artificial intelligence centers funded by the National Science Foundation. And these are large investments aligned with the National Research and Development Plan. And they're actually going to fund 7 more. And so we're here in Colorado. And when we were thinking about launching our center, we had to think about how do we think about AI in education in a way that's a little different from how we've been thinking about it in the past. So in the past, we think about this vision of a computer working with the student one-on-one. And I personally have worked in that vision for a long time. And actually, I find it pretty depressing vision now that I think about it, because what is learning? Learning is about people coming together. This is a learning opportunity. It's people interacting, it's people talking, and it's a social endeavor. So we're thinking, how can AI support learning in a way that's different from this one human, one computer kind of perspective? So we're a large institute. We have about 9 universities, and we work with public schools and a lot of nonprofit organizations. And so we're a broad team of folks, and kind of the lifeblood of us are the students and postdocs who work together. So I'd love to think about ways in which you can get involved. So let me just say, what are some opportunities for innovation in AI in education? Well, one is thinking about enhancing the bandwidth of communication. So instead of a computer and a human, and there's some values to that, thinking about multimodal, being able to look into a classroom and sense what's going on, multi-party, many people talking together and having a conversation, and naturalistic. So people can gesture, talk, speak. So there are some fundamental AI challenges there to figure out how to do that. The second is developing the whole student. There is not enough time to proceed as we are, where you do STEM and you do literacy as these disconnected subjects when we're facing such crises in the world, global warming. I'm personally in Colorado deeply affected by it. I can't even tell you the number of times we've been in meetings and people have to run off because they have to pack their homes because of fires. So that's a calamity that we have to deal with. Similarly, COVID, this involves people coming together to solve really complex problems. And so the idea is, how do you think about education that develops the whole person? So while you're learning math, can you also learn something about scientific reasoning? Can you also learn something about character, learning about persistence, creativity, and so on? And lastly, as we just heard, if you were in the talk before, we've proceeded in this kind of naivety that we have the best intentions, right? But what we've learned from big tech and everything is that we just don't have that luxury anymore. So really thinking from the ground up of what does it look like to have ethical and equitable AI in classrooms, because we're talking about children, and how can we, and asking these questions of what AI should do rather than what it can do. So previously, fairness, ethics, these were always afterthoughts. And we said in our institute, let's put these as centerpieces of the design. Let's make these constraints from the ground up. So what I'd like to share with you today is how we're thinking about these ideas, along with some kind of research results. And I'll try to end pretty quickly to have some time for questions and discussion. So we asked ourselves, let's take the following challenge. How do we promote deep conceptual learning through these rich socio-collaborative learning experiences for all students? Well, basically, it's been known forever. People learn by telling and doing, and learning is inherently a social activity, right? And folks in education know this, good teachers know this. The challenge is it's really hard to do. I taught an AI course at CU Boulder like 3 years ago with 106 students, and I tried to have one collaborative activity in every class. And I'll tell you, with 50 groups running around, I was like running around, they're all working. But when I was lecturing, everything was silent. And suddenly the whole classroom would come alive, but it was really hard to track what's going on. And I was doing this twice a week. Think about teachers who are doing this 5 times a day, 5 days a week. And it's really a testament how exhausting it is into their dedication. So we asked, how can AI support this? And the challenges that occur are, so in our view, we thought about AI in a different way, as the social collaborative partner that helps students and teachers work and learn in a more effective, engaging, and equitable way. So you can think about the AI having many roles, and we are still figuring out what's the form, right? It could be a disembodied voice, it could be a kind of computer simulation, it could even be a robotic system. But what it's really doing is it's listening in and participating in these conversations that kids are having about some learning materials. At the same time, it's sending information to the teachers, because we always want a vision in which the teachers are in charge. They know what's best for their students. So how can the AI help teachers orchestrate classrooms to have these rich socio-collaborative experiences? The second thing is that we got to think about, we're working towards AI literacy. So we're developing curricula to teach AI. So using AI to teach AI. So one reality is there's no standards for AI in classrooms right now. But we're living in a world which is totally dominated by AI. So we're thinking about how can we make curriculum that helps kids learn about artificial intelligence. But to do that, we're embedding it in existing courses. So we're helping students learn about STEM and AI content knowledge, but also thinking about how to come together to solve problems. So a big emphasis is collaborative problem solving. How do people come together to solve a complex problem that requires creativity? At the same time, how do you have rich discourse? So when you're thinking about learning, what are the conversations that kids need to have? And at the same time, we want to teach kids about AI is powerful, about the nature, behavior, power, and consequences of AI systems in their lives. And lastly, we are adopting a framework of responsible innovation. So these are a set of guidelines and ideas that you think from the ground up about how to develop technology that can be fair and unbiased, but also serves the needs of the kids and their parents and different stakeholders. So this framework, the way to think about it is this idea of taking care of the future through collective stewardship of science and innovation in the present. So I'll give you some examples of how we operationalize this framework in our institute. So very briefly, and if you're thinking about going to grad school and careers in tech and everything, it's really important to realize that to solve these problems, you really need to get people to come together who are very, very different and don't talk to each other. So one of the major things we're trying to do is get folks to come together. So we have researchers, and we divided our institute into these 3 research strands. So strand 1, these are the hardcore AI folks, and they're really focusing on computer vision, machine learning, speech recognition, natural language understanding. And on the other side, you have folks who are educators, who've been working on curriculum, working in schools, working with the school districts, and figuring out how to get those 2 to talk is really been an interesting journey and a challenge. And in the middle, there are people who work in human-computer interaction, in computer-supported collaborative learning, and in team science. So thinking about, because we're working in teams, how to get this all to work together. So I want to tell you a little bit about some research today that's at the intersection of these different areas. What we're really thinking is something like this, and just to think about a theory of change, how are we going to get learning outcomes that are meaningful? This has to be intentional, it just doesn't happen. And we start with curriculum units. So we design curricula, we work with kids themselves to think about what is it that they want to learn and how do they want to make impact in their society. And that is like the nugget in which we build the whole curriculum. So, and this is the way you can actually get them to be engaged from the ground up. But then, in addition to good curricula, can we actually then support them to have rich learning conversations? And I'll show you some videos of how we're trying to attempt to do this. And then the third part that comes together is how can AI help? So how can the AI partners, what we're calling it, help facilitate these conversations? So there's kind of 3 levels here: good curriculum, rich experiences, and how AI can help. So let me just tell you very quickly. So the way we look at our work, and we start with this idea of learning futures workshops. So we engage kids from, in this case, from Berkeley and Colorado, because that's where we happen to be. We sit down with them for hours and days and asking them, what is your fears? What are your concerns? What are your wants and what are your desires about AI in education? And that's kind of the nugget in which we proceed. So here's what we did. So this is during COVID, and then we did this in person. We've had 2 learning futures workshops, and it really helped us reconceptualize how we thought about AI in education. So basically, here's what they told us. The kids told us they want to have affirming interactions with an AI partner, and they want their voices heard. They really cared about building relationships with one another and with their teachers. That was their primary concern. They wanted their contributions heard, attributed, and have meaning. So they wanted respect. Importantly, they didn't want the AI partner to be a snitch. They didn't want it reporting information to the teacher. However, they were fine with it reporting poor behavior of their peer students. They wanted agency over the AI partner. They wanted the ability to turn it off. What a concept. We never even thought about that. So they wanted an off button. And lastly, they actually felt they were very pragmatic. They would give up some of their data if there were features that they value, that they felt they could get in value. And this is one of the drawings that one of the kids did. And this is called a live, love, light log. And the idea is a really, really amazing idea. Basically, the students and the teachers negotiate what are the norms of the community that they want in their classroom. So they don't want curse words. They may want strong relationship building talk. And then the AI can sense what's going on in the classroom. And as certain events occur, these light up in different ways, both positive and negative. And that's just one of the ways in which they felt they wanted their contributions to be contributed. So then we took these ideas and we actually had a major design sprint where we got folks together. These are like our folks at the Institute, and they came together for 3 days. And this was pretty scary because this was in December, right during Delta and COVID, but we pulled it off. We didn't have a super spreader. And we started to think about how do we take these ideas and think about designs for new metaphors for the AI partner. And we actually came up with 3 pretty clever designs. One is that of a community builder. And this is something that supports students in developing trusting collaborative relationships with each other. And that light log is part of that. The second is an augmenter, helping relay information between teachers and students. So what is the information that students want to share and how does that go to the teachers? And the third one is more traditional. This is just supporting them during the actual tasks. But the important thing is this is a very, very different way of thinking about AI than we had thought about at first. When we wrote this proposal, we were thinking about this as this top-down thing that's a guide and a shepherd that the kids need monitoring and steered in the right direction. And they were not interested in that at all. What they actually wanted was a whole different way of interacting. And this is just an example of using design thinking and these processes of going back to the user to really think through what is it that kids really actually want. So let me just tell you and show you some things about classroom. So I mentioned curriculum. We're really fortunate to work with some amazing curriculum designers, and they have this is one of our first curriculum. Students, these are middle school kids, they learn about this concept of sensors. How does AI and computers use sensors to learn information and sense the world? So what they do is the teachers actually so they actually work with physical sensors, and the teachers build this display. It's called a sensor display, and it's just sitting there in the classroom. And kids come and they look at it and they don't even know what's happening. And this is meant to trigger what's called noticings and wonderings. They're like, why is this lighting up in this condition? What's happening? What it really is a sound sensor, it's a temperature sensor, an environmental sensor, and it senses soil moisture, and it displays that information. But so you don't know that at first. And then kids come together and they learn how to program these sensors. So we also teach them some computational thinking. So they work with the physical sensors. In this case, they're trying to diagnose where this plant is dying. It's because of the moisture levels and so on. And then they actually program things. So then they work first. Teams of kids become experts in individual sensors. So I may be an expert in the sound sensor, you may be an expert in the moisture sensor, and so on. Then they come together and we call it a jigsaw. So the sound person and the environmental person and the moisture person, and they try to build a display to solve some compelling problem in their society. So this is kind of what the curriculum looks like. And I'll just show you an example of some student interactions with it. So first, it's just learning about team norms. It's just a simple activity for that. So that's the microphone we use. And the reason it's so big there is to have a presence. People know it's there and they're not sneakily removing them and things like that. Anyway, so you get a sense. And so we actually, now to develop these AI algorithms, and you can notice the sound is actually pretty bad and the classroom is really noisy. So you need a lot of data. So we actually went in all through last year and we implemented, helped teachers implement this unit on like 1,000 students. And we collected data from about 500 of them. There's a whole bunch of data. I want to show you kind of what it looks like. And you want to think about how can an AI system make sense of what's actually happening in this really noisy kind of classroom environment. Just to show you the sensors first. So think about how an AI can try to make sense of what's occurring actually from this really noisy audio and teacher. So, and also we're trying to emulate some of the teacher's actions. This is why we record the teacher to try to then figure out how. Okay, so I want to just tell you a little bit very quickly. So we actually analyze this data from like many dimensions. So this is very like painful process, but basically we look at what they're saying, how are they saying it, and grounding what they're saying with gesture. So you can saw from the video, you can only send so much from the actual audio. How does it come together by understanding gestures? Then we actually focus a lot on analyzing talk. What is the types of talk they're having? And there's certain models and frameworks about talk that are supposed to be more beneficial for learning. So any talk is not good. So we look at collaborative problem solving frameworks, and then we look at how teachers and students support each other. And so this is how you look at this data from this kind of multi-dimensional angle. Just to give you an example, this is an example of the collaborative problem solving framework. What you actually do is you literally look at every single sentence they're saying, and you actually have codes. So for example, this is in the case of a physics game they're playing, we got like 2 minutes left, so we might be able to get all these levels. And then you look at that and you say, they're talking about the challenge situation because they're talking about 2 minutes left. And this is that meticulous process of where you actually go in the classrooms, get the data, transcribe it, annotate it, and then you kind of build your model. So I just want to say, like, thinking about AI and tech, it's really not so much about just sitting and getting a bunch of data and you can run your algorithms. It's really a full contact sport. You're kind of getting in there and you're getting immersive. And this is where that interdisciplinary experience is really, really key. So let me just show you some of the tech we've developed. So one of the ideas is kind of supporting this exchange of information. So one of the things that came out in this Learning Futures workshop is thinking about different ways in which you can coordinate information with students. So one idea we had is students can have their own little dashboards that displays in each group that gives some information to them based on what they want. There's some information they choose to share to the teachers, and everybody can choose different information they want to share. And lastly, there's this community dashboard where they talk about the norms, like that light log I mentioned earlier, in what are the affirming norms they want to share. So there's a lot of challenges in the tech involved here. So to give you a sense of what actually occurs, you have to like take the audio or video, and now we're only starting with audio, figure out what they're saying, who is saying what, recognize their speech, put it through a content analysis. What are the words being said? Understand conversational dynamics and discourse, and then understand collaboration. So it's like a lot of challenges that occur at many levels. And there's a lot of things. It's multi-party, it's multimodal, it's multi-curricular, and there's error at every levels. So the challenge is, how do we sense and make sense of something in a really, really noisy environment? And this is kind of where we're trying to push the foundational AI. So very quickly, people think speech recognition is a solved problem. It is really not. In our classroom studies, we have error rates of about 80%. So most of the speech recognition systems that are evaluated, people are literally reading from the Wall Street Journal. And that's how you typically evaluate speech recognition systems. But this is an example of some of our speech. So for example, these are 3 speech recognition systems, Google, Rev, and Watson, IBM. So they're saying just start the show number, and you can see many, many types of errors. So one of the key things we're trying to do is figure out how can you make sense when you have so much of noise in your data. And this is the key principle of AI in the field. You really have to learn to work with noisy inputs, but the key insight is you don't need perfect speech to get things to work. And there's ways in which you can take imperfect speech and figure out with downstream natural language processing techniques on how to make that happen. I'll show you an example of that. The second thing is analyzing collaboration. So this is pretty straightforward. We actually look at what they're saying, and then we have a transformer model, like a large language model, that basically tries to say each example of your speech is evidence of this type of speech indicator in this collaboration framework I showed you earlier. So think about something like this. People are having a talk, the audio is recorded, we use some machine learning, and for each utterance, we get some predictions on what is the likelihood that they're saying something. That is then compared to some norm data, and then you give them a score. You're like 57%. So it's this kind of long cycle. And lastly, we've also been analyzing the degree of task and topic-related talk, and this is a key area. The AI needs to know if the conversations are on topic, but the students are horrified if that information is shared with the teachers, right? Because that's literally snitching. So this is kind of how you navigate what the AI can sense, what it keeps privately, and what is kind of shared with the teacher. So we have some ways in which we can actually categorize that. Other quick things we've been doing is looking at dealing with multi-party speech when many people are speaking, thinking about how you can actually get gaze, automatically analyze who's looking at what and whom. And lastly, how to incorporate gestures, because very gestural activity, into analyzing speech. So let me just show you a little bit, just a quick demo that kind of illustrates what we're currently able to sense from the actual classroom. And this is intended for researchers. We wouldn't like give this to teachers or anything. This is just to give you a sense of what's occurring. So here's a little video. Yeah, so we're just getting started, and we can try to sense a few things that are occurring in the classrooms, which is a very, very noisy environment. So let me just end by talking a little bit briefly about, because many of you are going to get into careers and may already be in careers and thinking about the future, on kind of how you get people to work across disciplines, because that really is kind of the future, right? And if you were at the previous talk, she was talking about how you get journalism to work with data scientists who speak very different things, and they actually have different value systems. And I've been very fortunate my whole career, always worked at these intersections, but it can be actually challenging on how you navigate those. And the other thing we have 9 universities all across the country. So how do we actually get everybody to kind of talk? And we launched this whole institute during COVID. So that was also not fun. We represent actually 14 different research areas. So just to be able to pull off that little 2-minute demo that I showed you, it really involves experts in natural language processing, dialogue management, foundational AI. Then you have folks from the learning sciences who think about the science of broadening participation, how to make inclusive designs, and then you have folks in team science. So it's really this combination of people, and these are actually people at these different research strands and how they kind of come together. So that's been a really interesting challenge, and we're still figuring out kind of how to do it. For example, a lot of people here don't actually believe that AI belongs in classrooms. So, and that's a really fundamental perspective, and they are really concerned with surveillance and concerns about AI, surveilling students, snitching on students, and how we incorporate those in respectful conversations. And so one thing we do is what we call this conjecture mapping. And this is a way you can get people to come together to actually think about a certain design feature. So here's one. This is focusing on off-topic talk. What can a system do? So think about a computer we showed you who can classify if a talk is off-topic, right? So that's the back-end decision. You can think about how to show it in the front end. What do you display? So in this case, one conjecture is the dashboard alerts youth when topic changes in collaboration, and youth can decide to elect to tell teachers about what's occurring. And then we think about how can that process lead to some learning outcomes? Well, remember, we're trying to teach them AI literacy. So can we actually use their own talk to teach them how is the computer classifying your talk as being on and off topic? Is there bias in the system? How does that actually occur? And then there's also theories that show off-topic talk is not bad. It helps students build rapport, it relieves pressure. It actually is part of having a good conversation. So connecting these pieces together, we found that this tool is really helpful to get folks to sit together from different backgrounds and actually have these conversations. Because you have people who are thinking about, what is the back-end AI algorithm? What is the front end? What is the theory? How does it come together? The other thing is actually thinking about the long journey to develop technology, right? So I talked to you about this, working with the students to come up with these learning futures workshops, then designing things together. And then these mappings, I talked about the conjecture maps, and then we come together and develop some algorithms, then there's designs, and then finally it comes back to this. This is really this long arc, but it's really exciting because you're not sitting in a cubicle isolated working on a problem. You're in the field, you're working with people, you're working with teams, and it's really, really cool. And this is just an example of what we've been doing, just working together. And I think I'll just tell you, it's really exciting from a lot of natural language processing people who typically work with corpora. They have, maybe never really spoken with a human in a research sense, and now they're in classrooms collecting data, and it's actually horrifying sometimes to think about going to a middle school classroom. But it's super exciting, and then we do all these kinds of things. So I just want to say, check us out and on our website and look at ways you can get involved. We're always looking to get young folks involved in our research. And thank you so much. Yeah.
Hi, thank you for the presentation. I guess I have like two questions. So it seems like the presentation was pretty heavily focused on like the student perspective in all this, which is obviously very important. Is there any work being done to accommodate teachers who do not have technical literacy, whose like bandwidth is like very stretched because maybe they're like working in a classroom with limited resources, multiple languages going on, and don't have the ability to like troubleshoot things when things aren't working with the AI? That's the first question. And the second question is, you like shown a diagram with like the community hub and like the three kind of parties engaging with that, and I would be curious if that's something like we've built out and like what it looks more like in practice.
Thank you. These are thanks for your excellent questions. The first question, we actually work very closely with teachers, and we just started out with students, but the next set of workshops will actually focus on teachers. So when we initially thought, and we have a teacher, we call it the TAB, the Teacher Advisory Board, and we work with a lot of them. When we originally thought about teachers, and you think about dashboards, it conjures up this vision of blended learning. So kids are working alone on Khan Academy or something, and you're sensing aspects of their progress and displaying it to teachers, right? But this is very different with these teachers in this classroom. It's very immersive. They're going around and they have no interest in some real-time live dashboard giving them information because it's complete overload. So it's led us to completely reconceptualize our thinking. One thing we're working on is how to teach kids, or how to help kids develop collaboration skills, and nobody really knows how to do that. So we've spent a lot of time assessing those skills. So what we're going to spend this entire year is work very closely with teachers to see how we can support collaboration. And then what we do in the summers is we have, in fact, we just did this last week, we have 1 week professional learning workshops for teachers where they come in and we help them with the tech and kind of help them co-design with us. So a key piece here is co-design. I've got to mention that. It's really where you get people together and you kind of design together. So teachers are very much in the picture. But in addition to teachers, we're also working with parents. So, in terms of AI, people have Hollywood has really ruined people's perceptions of AI. It's either dystopia or it's, very benevolent AI that can solve all your problems. The reality is, AI is really pretty terrible right now and will be for a while. And so really reconceptualizing this conversation about AI is something we want to do with parents because we're really concerned. Because people can find it, kind of off-putting, and we want to negotiate this correctly. And also working with community leaders, because there's genuine concerns about AI and incarceration, surveillance, and all kinds of things that we want to kind of prevent against. To your second question, it's really been interesting. One of the best decisions we ever did was to think about this community hub, and we've got an amazing communications coordinator. But for her, the job of just keeping us connected was so much that we've now had to hire external people to do external outreach. And it's a work in progress, and we're kind of learning how to have these conversations, to be honest with you. And hopefully one day we'll actually write something about these experiences, because we study team science, so we should be studying ourselves. I will say that like we're about we've got certain things figured out, but there's certainly one of the challenges we have is people have different value systems. How do you get people to work together when they really value different perspectives? And that has been consistently something we're trying to figure out. One thing I'll say is that in the second Learning Futures workshops, one of our colleagues we took the kids to an 80% co-op where where people are forced to collaborate because that's how you live. And then they learned, and I think that's when some of these ideas came about shared norms and shared respect and shared values and so on and so forth. So just thinking through these lessons, how can we apply them to ourselves? So thank you for those questions. Yeah. Yeah. So in Colorado, we're working at Denver Public Schools, which is there's a large number of Hispanic kids, and so that's something we're collecting data on, and we're starting with just trying to understand how do the speech recognizers perform at baselines for kids with different backgrounds and everything. But then what we're going to do is train different. We've learned that we have to retrain our own speech recognizers essentially, because the acoustic environment of the classrooms is just so different from what's out there. So we're starting with training the speech recognizers, and speech recognition occurs in two ways. You train the acoustic model, and then you train a language model, which is what people are saying. So we start with the acoustic models, but then we're probably going to have to train separate language models to accommodate different, this idea of translingualism, where people speak multiple languages and they go in and out of these conversations. So this is exactly an area where we actually think we can make some foundational advances in AI. So not just, so in addition to incorporating gesture and speech, but also being able to figure out how to incorporate multiple languages. So that's very much on the agenda, and we're in this data collection phase right now. Yeah, thank you. Yeah.
Thank you. One of my questions was just asked about the accent and dialects, but I guess I still have one more question about bias identification and mitigation, because the biggest part of AI is that it is programmed by humans, right? And then we all have intrinsic biases in some way, and maybe extrinsic, and we may not know, right? And the biggest part is identifying that there is a bias and trying to mitigate that. For instance, there are a lot of kids that are on the spectrum, for example, and it's quite difficult to figure out, on what basis. However, through constant conversations and all of that, perhaps we may be able to do that. Then, are there ways or methods in which you're planning to kind of personalize some form of working together, because it depends on how that kind of student is, to be able to say this way the student will be best able to collaborate is working with just maybe one person from 6 feet away, because I have worked with an organization with the autistic people before, and the thing is, it's just quite difficult for some people more than others, right? And it's like a thought as well. I just believe more intentionality of identifying bias and trying to make it helps AI perform better. So yeah, just a thought on that.
No, very much. Thank you so much for that thought. So just two quick things there. For the last 3 years on a separate project, we've been working on, so one of the areas I work in is called affective computing, which is computing involving emotion. You can imagine there's a lot of bias concerns there. So we actually have, because what people do is you have to watch somebody's video and then make a judgment what their emotion is, what their personality is, right? Full of bias. So we've actually worked on an entire framework on how bias creeps in at many levels. People think you just need to get representative data and your bias problems are solved. Absolutely not. That's a starting point, and that's the initial point. So we are working with a framework, and I'd love to share it with you, of how you can invest different kind of parts of the pipeline. So that's the first thing there, and we're going to apply this to this. The second thing you raised is a really, really great point. What is effective collaboration? One of the things, so I can come in with my theoretical viewpoint on what collaboration should be like, but I'm coming in from a perspective and from a cultural perspective that is Western and could be very and you know neurotypical and so on and so forth, right? So one of the things we're doing at this institute is research, and we're saying people talk in different ways and supporting non-normative forms of talk. So we don't want to impose a way of collaborating